Welcome to the lectures on problem solving and programming in C. This is lecture 28 and the title of the lecture is Array Statistics. In the last few lectures, we have seen how to read elements of an array and how to display them, and we have seen some other how to compute minimum maximum of the array elements. In this lecture, we will see how to compute some other statistics of the array elements. For example, how to compute mean of the elements, how to compute the median, which is the middle element after elements are sorted. Then mode. Mode is basically most frequently appearing element, right? Let us go and discuss one by one. What is the mean? Mean of the elements? Mean. Mean is equal to sum of the elements. Sum of the elements by n, where n is the number of elements. Number of elements. Okay. We know how to compute sum. So, right, let us write the algorithm for this mean. Algorithm. Mean. List mean. Mean. Input. N greater than equal greater than 0 and n numbers. Okay. Output. Mean of the elements. The n elements. Mean or average. This is also called average. Okay. Average. Mean is also called average. Mean of the n elements. Okay. So begin. Let us take input n and input validation on n. If n less than or equal to 0, then output invalid input and then stop, and if after this, if n is valid, we need to declare n, a list of n elements. Then we need to read for I equal to 0 to n minus 1, do input L of I, end for right. Then after that, we need to sum up the elements, right? Sum equal to 0. This we have done in previous, I think, a few classes back. We have seen how to compute sum of a sequence of elements. We need to use the same logic. So for I equal to 0 to n minus 1, do. Okay. Sum equal to sum plus L of I, end for. We are adding each element to the sum. Okay. So now we have the sum of the elements. Average is output sum divided by n, end. This is the average, right? Let us type this program. Pi mean.c. So let us copy this program. The array statistics is there, right? So list max. I will copy this program to mean.c. Pi mean. So what will be there? Number will be, this is input n, then input validation, list is in, and then list reading is there, right? Everything is there. Up to here, we have already have the code. What we need to do? Int sum equal to 0. And for int I equal to 0, I less than n, I plus plus, I plus plus, sum equal to sum plus L of I. Output, output. So we need to read printf. See when sum is integer, but n is also integer, but the average can be fractional value, decimal. I mean fractional floating point. So we need to say average is equal to percent f. So let us say we need to typecast. This is called typecasting operator. Float sum divided by n. Let us see what it happens. This is the program. Let's compile this. GCC mean.c. Yes, compiled. Let us give 10 numbers and then give from 1 to 10. The mean should be 5. 5.5. 5.5. That's okay. 55 by 10. So sum of the first 10 elements is 55. And 55 5 is 5.5. Okay. Suppose if I omit this, if I don't include this float, okay, what happens is it will do a integer division, then you will only get 10. 10 elements, same numbers I will give 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 now you are getting 0 only. Why you are getting 0? Oh, okay. So, okay. See here, this is a problem here. So let us be %d here, integer, %d. 10 elements, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5. Okay, earlier we were getting 5.5, now we are getting 5 because of the integer division. Okay, that is why we need to display typecast the sum to either sum or n to this float. Okay, so that it will display the average with fractional values also like this. Okay, right. Let me show you the code one more time. So this is input reading n value, number of elements. This is input validation. This is the list array is declared, array of n elements is declared. And then this logic is to read the array elements. Then this logic is to sum up the array elements. We are taking the sum as 0. Then we are adding the elements one by one to the sum. So that eventually at the end of this for loop, the sum will contain the sum of the all n elements. And then average is sum by n. Right? Now let us move on to the next problem, median. What is median? Median is median. Median is basically middle element middle element of the array after sorting the elements. Okay, any sorting I'm thinking in ascending order, let's say in non-decreasing order. Okay, non-decreasing order. So let us take so array elements 5, 20, 2, 10, 8, 35, 41, like this. If this is the array, what is the sorted order in if you are arranging them in non-decreasing order? To sorted order. 2, 5, 8, 10, 20, 35, 41. Okay, this is order. This is the sorted order. What is the middle element? Middle element is this. Okay. So median of these elements is is 10. What happens if, since here we have even number of elements n equal to, here n is how much? 7. So which is odd number. That is why we'll get only one median. What if suppose if I add one more element here, let's say 8, and more element 8. So what will be the sorted order? 2, 5, 8, 8, 10, 20, 35, 41. Okay. Then in that case, we will have two middle elements. Okay. So what will be the median? Median can be, we can say, take average of these two. 8 plus 1, 8 plus 10 by 2 is equal to 9. 9 can be median, or you can even say this leftmost number. So n equal to 8. So 8 by 2. 8 by 2 is how much? 8 minus 1 by 2. We can say 8 minus 1 by 2, which is 3. 7 by 2 is 3.5, so which is integer division is 3. So this is 0, 1, 2, 3. Third element we can say. Best thing is to take the average of the last two. So this is basically 3 minus, so 8 minus 1 by 2, and index 8 by 2. 3 and 4 elements. These n minus 1 by 2, n minus 1 by 2, comma n by 2. These are the two middle elements. If the number of elements is even. Okay. If the number of elements are odd, we just need to say n by 2. 7 by 2 is 3. Okay. So let us do this. Since we already see, first thing is to get the median, we need to sort the array elements. Okay. There are other ways to do without sorting also we can do, but that is not part of this course. So what we'll do is we will sort the array elements and then print the median of the array elements. Since we have already have this code, I will explain you the code directly. Where is the sorting? CP sorting median. Okay, VI median. So we have read the n number of elements, put validation, then we have declared an array of n elements, then we have read the array elements, and then this is we have sorted. Okay. This function insert and sort will sort the array elements, right? We are using the insert and sort to sort them. Now what is the answer? What is the median? Suppose if int float median is equal to median. Okay. What is the median if n is odd? If n% 2 equal to 0, 0 equal to 1. This means that it is an odd number, right? N is an odd number. Then what will be the median? Median equal to L of n by 2. The middle, exactly the middle element. Okay. Else median equal to L of n minus 1 by 2 plus L of n by 2 division 2. Okay. We need to sum these two and then division 2. Then we just need to print of average, print of median. Median equal to %f comma median. Okay. If the number of elements is odd, we have exactly one middle element. That is why median is present at L n by 2. If the number of elements are even, then we have two medians, and then we are going to take out the average of those two medians. So L n minus 1 by 2 is the first median, L n by 2 is the second median. We are summing them up, and then division by 2 will give us the average. Then computing the median, displaying the median. This is the insertion part function which I have discussed in the last. Let us compile this. Yes. Let us give the same element, 7 elements, whatever is given here. 5, 2, 5, 20, 5, 20, 2, 10, 8, 10, 8, 10, 8, 35, 41. 35, 41. So 10 is the median. We got the 10, right? 10 is the median. Now let us run the again with give a odd even number, 8 numbers, 5, 20, 2, 10, 8, 35, 41, then followed by another 8, another 8. So 9 is the median because it is the average of 8 and 10. 9 is the median, right? This way, median is basically a middle element after sorting the array elements. So what we need to do, we read the number of elements, we sort the we read the actual elements, n elements, and then we sort them and then display the middle element. If the number of elements is odd, we have only one middle element, that will be the median. Other, if the number of elements are even, we'll have two middle elements, we'll take out the average of those two middle elements, that will be the median, right? Let us move on to the next problem, mode. What is mode? Mode is mode. Mode is basically most frequent element in the most frequent element in the array. For example, if you take 1, 2, 1, 5, 7, 6, 7, 2, 1, 3, 4. If these are my array elements, what is the most frequent element? 1 is the most frequent element because it is appeared 3 times. What is the next most frequent element? 2. 2 has appeared 2 times. So the one mode is 1. So if you understand this problem, so see, basically we need to compute for each element. We need to check how many times the element has appeared in the list, this array. Okay, and then that is called what we call frequency of an element. And then we can take the mode. Mode will be the element which has maximum frequency. Okay, so that is why we need to compute the frequency of an element. Okay, so let us write a function for this function procedure. Frequency. So we'll get n, a list of 0 to n minus 1 elements, and then an element e. What you need to return? Input, an array of n elements, and an element e. In writing algorithm, I'm not using numbers, I'm using element, because when you convert this to a C program, the data can be integer, the data can be characters, the data can be floating point numbers, like that. So the same algorithm can be used for different variety of data. That is why I'm writing in generic way, and mentioning it as elements. Okay, what is the output? Put returns frequency of e. Okay, begin, right? So how do you check? What I will do is, I will say that frequency f equal to 0. What I will do, I will go through the array elements one by one and check if the array elements is equal to e or not. If it is equal, then frequency will be incremented by 1. So for I equal to 0 to n minus 1, do if L of I is equal to e, then f equal to f plus 1. And if, and for, by the time I complete this for loop, I have processed all the elements and then checked what are the elements which are equal to e, and then frequency is updated accordingly. So we just need to return the f value here. This is the procedure which takes a list and an element E as input, and then returns the number of times the element E has occurred in the array, which we call the frequency of the element E. Okay. Now what we will do is using this, how can I use this procedure to compute the mode? What I can do is I will compute, I will call this function on L0. As I pass L0 as E value. Okay. And then L1 and L2. Every time I will maintain the maximum frequency and then maximum element we have seen so far. Okay. Uh, and then so that we can display that at the end of the iteration. So let us write algorithm mode input n greater than or equal to n greater than 0 and n elements, output mode of the array begin. Okay, so I think we can take these portions, input validation, input reading and all from here. Up to here. Yes. So we have read the input value, input validation, and then declared the array list, and then we have read the input elements. Then what we need to do? We need to, so so let us say maximum element is most frequent element is L0. Okay. MF. Most frequent element is L0. Okay. And then frequency, max frequency. Max frequency is 0. Let us say 0. Let us assume that it's 0. Okay. Yeah. Now what we need to do? Now let us, we can, no need of this. Okay, right. If, sorry, for, we need to traverse to the I equal to 0 to n minus 1, do. Each element we need to do, okay. Frequency is equal to, frequency, the function we will call frequency of n comma L comma L of I. Instead of E value, we are passing L0, L1 like that. If you pass L0, what you will get? We will get how many times the array element L0 is appearing in the array. Okay, that will be the frequency of L0. So what happens if this F is greater than, if F is greater than max frequency? What does it mean? This, so far this element Li is the maximally is the mode of the array. So far in the within the so far we have seen elements seen in the array. So max frequency, max frequent element is L of I, and max frequency is F, and if. Okay, and for. So by the time we complete this, what we will get is, we'll get the F as the max F is the max frequency output MF. MF is the most frequent element. We can even display max F also. Its frequency also we can display. Okay. And then end. Let us implement this function. So cp median. Copy this to mode. vi mode. So this will input n is declared, n is read, input validator, list is declared. So we have read the input elements. So, and then after that, we need to write int max frequent is equal to L0, int max frequency is equal to 0, and there is a for loop. There is a for loop. For int I equal to 0, I less than n, I plus plus. And there is an if statement. If there is a function called free, f equal to int f equal to frequency of n comma l comma l of I. Then there is an if statement if f is greater than max frequency. Then what we need to do? We need to update the so let's say take this as mode. This is mode. Let us correct it. This is mode. Mode equal to right mode. So let us say mode equal to L0. Then if f greater than max frequency, mode equal to L of I. Then max frequency equal to f. Right? Then printf, we just need to display the element mode equal to %d and its frequency equal to %d, comma mode, comma max frequency. Okay. So we need to define this function frequency function. So it returns the integer, right? Because frequency of int n, comma int l is an array, comma int e. This is the function. So so we need to declare the int f equal to 0. Int I equal to 0, I less than n, I plus plus. If L of I is equal to E, then f plus plus. F is equal to f plus 1, I can do f plus plus, right? And after that, return f. Right. So the same function, I need to declare it. Declare the prototype at the top. That's it. Okay. Let us compile this. This is the mode. It is compiled. Okay. Number of elements. Let us give what is the number of elements? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 elements. What is the element? 1, 2, 1. 1, 2, 1. 5, 6, 7. 5, 6, 7. 2, 1, 3, 4. 2, 1, 3, 4. Mode is 1, its frequency is 3. The mode is 1 because 1 has appeared 3 times, right? It is frequency is 1. So suppose if I give 8 numbers, all are unique. Every element is a mode. So, but we will display the first element. Okay. First element mode is 1, its frequency is 1. Okay. Right. We are not displaying all the elements which has maximum frequency. This program will display only one element which has the maximum frequency. Okay. Right. This is the mode. Let us go through the code one more time. This is a function which takes an array and an element E and returns how many times the element E is appearing in the array L. Okay. After that, we read the number of elements, input validated n, declared an array of n elements, then read the array elements. Then this logic is to, we are going through the elements one by one and computing the what is its frequency, and we are maintaining what is the most frequent element we have seen so far. Okay. So whichever is the maximum frequency element, that element, and then its frequency we are displaying. Okay. I will stop here. Thank you.